At our next section, 6.2, which is about rational numbers as exponents, right? Rational numbers as exponents. A really nice section here, because what it's telling us that exponents can be rational. Let's not forget that what rational means, rational is another way of saying a fraction. So here we're saying that exponents may be fractions. Right? Exponent, and that's huge. Right? The fact that exponents can be fractions. Right? So you as a college algebra student or as a math student are really evolving to be this college algebra student, because this is something that is taught very early on, or not even this one yet, 2 to the power of 2, right? 2 to the power of 3, 2 to the power of 5. Right? Then, as your math skills advance, you learn that 2 to the power of 0 is positive. Possible. 2 to the power of -1, 2 to the power of -2, 2 to the power of -3. Those are possible. But now we're saying exponents can be fractions. So we're saying that this is possible. This is possible. This is possible. That is what we're looking at in this section. Exponents can be fractions now. Right? And one thing that we can always do is we can always rewrite exponents to radicals. So we talked about square roots in the last section. We talked about cube roots in the last section and kth roots in the last section. But let's talk about what we really call those type of expressions. Right? So a square root, cube root, kth root are called radical expressions. Are called radical expressions. So this radical expression right? This radical expression can be looked at in the form of the nth root of A. This can be called the root or the index. This is specifically the radical symbol. Anything in the inside we call the radicand. So this is the general form of a radical expression. So now the question is, how do we simplify something like 4 to the power of 1 over 2? Right? How do we simplify something like this? Well, number one, this is just numbers. You can put it in your calculator. Right? You can easily put it in your calculator and it gives you the answer. Right? But I'm going to want to see work. All right. When it comes to your test, I'm going to want you to show me how you got that. Right? Because if you just give me the answer, you're not going to get full credit. Right? So we want to be able to simplify this, right? So what we can do is that we can rewrite an exponential form to a radical form. This is huge. We can rewrite an exponential form to a radical form. Because this is exponential form. And according to what this is telling us, is that we're saying that this exponential form, let's rewrite it. Let's rewrite it so it looks like a radical. All right? That is what we're saying. So how do we do that, right? How do we do that is the real question. So a very nice way of doing this right, are exponential form, let's say it's a to the power of m over n. Right? This is the same thing as a radical. But our radical has a radical symbol. Our base is now our radicand. Our denominator is our index. And the numerator is the exponent of your radical. These two notations are the same, just look different. Kind of like how $1 and 4 quarters are the same and look different. Kind of like how 1 over 2, which is a fraction, is the same thing as a decimal. Right? So these two things, even though they look different, mean the exact same thing. And also I want to note one other thing. I like to note that a radical with no index means it's has an index of 2. Right? Or in other words, it's the square root. So square root of 25 is really this 2 and the 25. But normally, we don't show it. We just show the power, the index of 3, index of 4, index of 5, and so forth. Okay, so let's take a look here. All right, we said that this and that are the same thing. And the first problem I want you to simplify is 4 to the power 1 over 2. Because if I give you this problem on the test, or something similar to it, I don't just want the answer. Because if you show me the answer, you're not going to get much points, which I saw to be a case with a lot of students. So we want to rewrite it. I'm going to show it as a radical. That stays the same. The 4 is now my radicand. The denominator is the index, so the 2 goes there. The numerator goes in the inside, so that goes there. I just mentioned on a previous note that we don't have to show that 2, so this is just really, and 4 to the power of 1 is just 4. So this is just really the square root of 4. And this answer is so a nice example, which means I expect to see some of these steps if you see a problem like this on the test. If you just say, I'm going to say, okay, you get 1 point out of 5 points, which means on this problem, you have 20%. So don't do that. Show me steps. Questions with this first example. Okay, let's take a look at some other ones then. How about I want you to rewrite without rational exponents. 16th root of 3 over 4. And then simplify if you can. So we're going to show it as a radical. 4 goes out here, 16 and 3 go in there. All right, keep the 4. Now you do your 16 to the power of a 3. Right? Gives you that. Then from there, you should be able to work this out by putting it into your calculator and working it out if you wanted to. It gives you an answer of 8. Once again, 8 times 8 times 8 times 8 should give us that answer. Any questions with this example? Okay, moving on. What you'll also be required to know in this homework assignment are your exponent rules. All right, so in order to do some problems, you'll need to know your exponent rules. Which we have a few of them, right? The product one tells us a to the power of m times a to the power of n was a to the power of m plus n. Another one is the quotient rule. Tells us a to the power of m over a to the power of n was a to the power of m minus n. The power rule tells us open parentheses, a to the power of m, close parentheses to the power of n equals a to the power of m times n. How about the negative exponent rule? So this a to the power of negative m equals a to the power, equals 1 over a to the power of m. All right, so these are some of the rules that you'll be using to simplify from some of these problems on your homework. So let's take a look. I want you to rewrite with positive exponents. -2x to the power of negative 1 over 7. Okay, so, right, we can rewrite this as 2 times x to the power of negative 1 over 7. All right, when they're next to each other, it means multiplication. Now from there, we can apply the negative exponents rule. All right, we have a negative exponent, so we rewrite that as 1 over x to the power of 1 over 7 times 2. Now we can go ahead and put this back together, right? And this is just really 2 over x to the power of 1 over 7. Any questions with this example? Okay, next example. Rewrite with a rational exponent. 4 over the third root of x. So now they want us to write this with a rational exponent. All right. So really taking a look at this bottom part. I'm going to show that this x has a power of 1. Because now I can rewrite it, right? I can use my rule that says a to the power of m over n is the same thing like the nth root of a to the m. Now, I'm getting rid of this. I'm going this way, which means it'd be x to the power of 1 over 3. And I wrote it as a fraction of an exponent, because that's what rational means. Any questions? Okay, moving on. Simplify. 5 to the power of 3 over 8 to the power of 2 over 11. All right, so this is an example where we'll have to use the product rule, all right, which is 5 to the power of 3 over 8 times 2 over 11. Now from there, you just go ahead and simplify this. right? You're multiplying fractions, so you can do some cancellation. 2 and 8 are both divisible by 2. That's a 1, and that's a 4. Right, sort of with 5 to the power of 3 over 44. Any questions? Okay, you want me to leave it for another minute? Just let me know when you're ready.
So on the fraction you just did, what can go into the denominator and numerator up top?
Yep, exactly. 2 is divisible by 2. You can divide that by 2 to get 1, and you can also divide that by 2. You have to divide them both by the same number.
Okay.
Very good.
Okay.
You ready?
Yeah.
Okay, here we go. Simplify. 8 to the power of 14 over 3 times a to the power of 5 over 6. This time we are multiplying them, which means we are going to add these unlike fractions, which means we have to find LCD. And our LCD here is 2. Which means I got to times this by 2 times that by 2. All right, so now what do we get? 28 over 6 plus 5 over 6. And now we can add the tops. Are those A's or 9's? They're A's. The letter A. So we get a to the power of a 33, 28, 33 over 6, which reduces a to the power of what? 11 over 2. Any questions? Okay, and let's do one last one. Simplify. X to the power of 11 over 6 over y to the power of 1 over 3. That's taken to the power of negative 3 over 11. So we have to apply the product rule, which means we're going to multiply. Yeah, we're going to multiply. So this is going to be x to the power of 11 over 6 times the negative 3 over 11 over y to the power of 1 over 3 times the negative 3 over 11. I see I can do some cancellation. I see 11s on the tops. Those are divisible by 3. So that's a 1, that's a 2. These cancel out there as well. So what are we left with? On the top, it's just x and a negative 1 over 2. And on the bottom, it's a y and a negative 1 over 11. Don't forget your negative signs. And now we see that both of these are negative exponents. So because they're both negative exponents, we have to relocate them. Right? Which means this negative exponent on the top is going to go to the bottom. This one on the bottom is going to go to the top. So we get y 1 over 11, x 1 over 2. And that is this answer here simplified. And there's more problems to practice, but our time is up here, so we'll call it a day. Any questions, comments, concerns? Okay, then. Well, y'all have a good...
Wait. Did you flip that? You flipped it?
Correct.
Okay.
And this is why, because really, we would write it as 1 over x to the power of 1 over 2, 1 over y to the power of 1 over 11. Which means what you're doing is you're dividing. Or in other words, you keep, you change, and you flip. And don't you get the same thing anyway? Yeah. Y and 1 over 11 on the top, and x and 1 over 2 on the bottom.
Okay.
But it's a lot easier just to flip them.
Right.
Very good. Okay, any other questions? All right, well then y'all have a good one, and we'll see you next time.
Thanks.
Bye. You're welcome.